Hi, this is the second video for the solutions to the 2020 Advanced HSC Maths paper. In this video, I'm going to look at section 2, booklet 1. Question 11. There are two tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres. So let's plot that point. And tank B is empty. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water is modelled by V is equal to 1,000 take 20T. V is the volume in litres, T is the time in minutes from when the tank began to lose water. On the grid, draw the graph of this model and label it as tank A. So we've got an initial starting point of 1,000 litres, and we know it's losing water at a constant rate of 20 litres per minute. And that's going to be a bit tricky to graph it per minute, so let's choose something a little bit bigger. Let's try T is equal to 10 minutes. V would be 1,000, take away 20 times 10, which is 1,000 take away 200 is 800. So after 10 minutes, so here, we're going to have 800 litres. Now we could continue to plot more points if we wanted to, but basically drawing those points into a line, we have got our straight line relationship and we've labelled it as tank A. Tank B remains empty until T equals 15, when water is added to it at a constant rate of 30 litres per minute. By drawing a line on the grid, find the value of T when the two tanks contain the same volume of water. Okay, so we've got 0 water in the tank until T is equal to 15, and then it is added at a constant rate of 30 litres per minute. Again, very difficult to graph per minute, so let's try after 10 minutes. We would have 30 lots of 10, which is 300 litres. So after 10 minutes it'd be T equals 25, and we'll plot this point there. And again, we can continue plotting points and joining them up. We end up with our other straight line relationship, tank B. Now having a quick look at where those two lines meet, it looks to roughly be around about 29 minutes. So in answering the question, find the value of T when the two tanks contain the same volume of water. We're saying that's approximately equal to 29 minutes. Part C, using the graphs drawn or otherwise, find the value of T, and T has to be greater than 0, when the total volume of water in the two tanks is 1,000 litres. Okay, we just need to look at various points and see which one's going to fit. So we'll start here at T is equal to 15 minutes. The volume of water in tank B is 0, and in tank A is 700. Having a look at 20 minutes, we have got 150 litres here and 600 litres. What about here? This point here at 29 minutes, where they're both equal, they're a little bit over 400. At T equals 35, we've got 300 litres here and 600 there. So we're getting closer. At 40, we have got 200 litres and 750. And at T is equal to 45, we've got our answer. 100 litres in tank A and 900 litres in tank B. So our answer is T is equal to 45 minutes. Question 12, calculate the sum of the arithmetic series 4 plus 10 plus 16 plus ... plus 1,354. Now the trouble with this series is we don't know how many terms there are, so we're going to have to work that out first. But we do know that A, the first term, is 4, and D, the common difference, is 10 take away 4 is 6. So let's substitute into our formula for the nth term, A plus n minus 1D. Right, let's put in 1,354. It's going to be equal to 4 plus n minus 1 multiplied by 6. And just tidying this up and solving this equation, we are going to get, let's see, it's going to switch it around. 6n take 2 equals 1354. 6n is equal to 1356. And dividing by 6, let me grab my calculator. 1356 divided by 6, I get 226. So there are 226 terms. And now to find the sum. I'm going to use this formula, but you could use the other one if you wanted to. So there are 226 terms. The first term is 4, the last term is 1354, And again on the calculator, 226 divided by 2 multiplied by 4 plus 1354, close my brackets, is 153 and 454. And there's our answer. Question 13. Evaluate the integral between 0 and pi/4 of sec squared dx. Now we know the integral of sec squared x is tan x. So this is pretty easy. We've got a definite integral, so I'm going to put it in square brackets, and we want to evaluate it between 0 and pi/4. Substitute in the pi/4. Take away, substitute in the 0. Tan of pi/4 is 1, tan of 0 is 0. Our answer is 1. Question 14. History and geography are two of the subjects students may decide to study. For a group of 40 students, the following is known. 7 students study neither history nor geography. 20 study history, 18 study geography. A student is chosen at random. By using a Venn diagram or otherwise, find the probability that the student studies both history and geography. I am going to use a Venn diagram because I find them quite useful. I have got a history circle and I have a geography circle, and I've overlapped them. Now the first thing we know is that 7 students study neither history nor geography, so that goes outside of those circles here. Now we need to find the overlap, because if we add up 7 and 20 and 18, we're going to get far more students than we actually have in real life. So let's figure out how much that overlap is. We're going to go 7 and 20 and 18. 8 and 7 is 15, carry the 1 gives us 45. Right, 45 students in here, but only 40 in real life. The overlap has to be 5, and that goes in the center there. Now what we need to do is figure out what goes in here and what goes in here. Let's start with history. Altogether we've got 20 students who study history. We've already counted 5 of them. In here has to go 15. Altogether in geography we've got 18 students. We've already counted 5. In here must go 13. We can do a quick check. 15 and 5 is 20, and 13 is 33, and 7 is 40. So we are correct. Now we've completed our Venn diagram, but we actually haven't answered the question. A student is chosen at random. Find the probability they study both history and geography. So that's our overlap, isn't it? That's going to be 5 students out of a total of 40. Now with probability, you can just leave it as an unsimplified fraction if you want to, but if you want to, you can reduce it down to 1/8. Part B, a student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? So this is a conditional probability question. Now you can use the formula if you want to, but I find it much more intuitive just to use the Venn diagram. So given that the student studies geography, that means out of the geography students, and there are 18 of them, what is the probability the student does not study history? Well, there's 13 of those, so it's going to be 13 out of 18. That's our answer. Part C, 2 different students are chosen at random, one after the other. What is the probability the first student studies history, the second student does not study history? Now, given we've got 2 different events happening in sequence, this lends itself towards a probability tree. And we want history and not history, 2 different students. Now we can make our life a little bit easier here. We want that the first student studies history, so that's this arm here, and the second one does not study history, so that's there. They're the only probabilities we need to fill in. Okay, the first student, what's the probability they study history? It must be 20 out of 40. Now, after we've chosen that history student, we've only got 19 history students left, so this one here would be 19 out of 39. But how many non-history students do we have left? We've got 13 and 7. So this would be 20 out of 39. When we go across the tree, we multiply. So we're going to go 20 on 40 multiplied by 20 on 39. Leave you to work that out. I reckon a few people would have got that question wrong because they would have just thought history or geography and disregarded these 7 students who don't study either. Question 15. Mr. Ali, Ms. Brown and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometres to location A. Ms. Brown walked with the rest of the students on a bearing of 100 degrees for 9 kilometres to location B. Show that the angle APB is 65 degrees. So that's fairly obvious, isn't it? Because this is 100 and that much is 35. So this angle in here is going to be 100 take away 35. We need to show some working out. So let's just do 100 take away 35 is 65 degrees. Find the distance AB. So let's construct that line and we need a pronumeral. Now because we've got a triangle here that has got something on all 3 sides and an included angle, this lends itself towards the cosine rule. I hope you're all saying that. So let's do that. X squared is equal to 7 squared plus 9 squared. Take 2 times 7 times 9 cos 65. And I'll just grab my calculator. We are going to do 7 squared, 49 plus 81. Take 2 times 7 times 9 times cos 65 and I get 76.75. We need the square root, of course, and that's going to give us 8.76 kilometres. Part C. Find the bearing of Ms. Brown's group from Mr. Ali's group. Give your answer correct to the nearest degree. Most important word with bearings questions is the word from, because whatever comes after it is where we put our compass. So we need to redraw the compass at point A, so in here. Now I want to go from north, clockwise direction until I hit that arm, so that's the angle that we're after. But we've got a bit of work to do first. I need to find the angle in this triangle, so I'm going to work that angle out first, and I'm going to use the sine rule to do it, because I've got an angle and its opposite side, and another angle and its opposite side. So we've got sine theta over 9 is equal to sine 65 over 8.76. We'll take our 9 up and over the other side, gives us that, and quickly on the calculator I get 9 times sine 65 divided by 8.76, which is 0.9311. Okay, that's not the answer, obviously. We want theta, not sine theta, so we need to do inverse sine of that number, which gives us inverse sine, that answer, 68.6 degrees, or to the nearest degree, 69 degrees. Okay, so that means that that angle in here, oops, is going to be 69 degrees in there. All right, we're still a bit of a way off, because we need to work out this angle. Now, it's getting a bit cluttered in there, so I'm going to redraw this diagram. I've got that angle there and that one there. We know that this whole thing is 69 degrees. We want that angle there. We need to work out this one. Okay, key to working out missing angles, I suppose, in bearings questions is alternate angles on parallel lines, and we have them here. We've got alternate angles there, because alternate angles on parallel lines are equal, and so that means that this angle in here is actually 35 degrees, which is here. All right, to work this one out here, I'm just going to go 69 take away 35, so in there is 34 degrees, and we're nearly there. This is a straight angle down here. I'm going to do 180 take away 34, which is going to give me 146 degrees, and that's actually our bearing. Question 16. Sketch the graph of the curve y equals negative x cubed plus 3x squared take away 1, labelling the stationary points and point of inflection. Don't determine the x-intercepts. All right, so stationary points occur when our first derivative is equal to 0. So let's differentiate negative 3x squared plus 6x. And we want to know where that's equal to 0. Let's factorize. So I've got negative 3x outside of x, take away 2 equals 0. And so our stationary points are going to be at x equals 0 and 2. We need the y coordinates. So at x equals 0, y is equal to, I'm just going to substitute back into here, negative 1. And at x is equal to 2, y is going to be equal to, let's see, negative 8 plus 12, take 1. So total is 4 is 3. Okay, so there are our stationary points. Now we need to find the point of inflection. So second derivative is equal to negative 6 plus negative 6x plus 6. And we want to solve this equal to 0. So x is going to be equal to 1. And again, we need to know what the y coordinate is. So at x equals 1, y is equal to negative 1 plus 3, take away 1 is 1. Okay, we should also test the concavity of our two stationary points here and here. And you should write this down. In order to get this 4 marks, you should write this down. So let's test here. I'm running out of room, sorry. At x is equal to 0, a second derivative, so I'm substituting it down here, is equal to 6, which is greater than 0. Therefore, it is concave up. And at x is equal to, what's the other one, 2. Our second derivative is equal to, so I'm substituting it again down here, negative 12 plus 6 negative 6. It's less than 0, therefore concave down. All right, we're ready to sketch. Now you need to make sure that your axes are to scale within themselves. So our y-axis has to be to scale and our x-axis has to be to scale. Now firstly, we want something here at 0, and we've got something happening at 2, and we've got something happening at 1. And we've got y coordinates, negative 1, okay, I think that'll fit, negative 1, and 1, 2, 3. Okay, 0, negative 1 is in here, and that is concave up. We have an inflection at 1, 1, which is here, and we have got a maximum at 2, 3. All right, here we go. Don't like the look of it, but it's not very easy to draw on these things. Okay, we didn't have to say where the x-intercepts were, so we should put arrows on the end, and you should also label these points. So this is a maximum at the point 2, 3. We have an inflection here at the point 1, 1, and we have a minimum here at the point 0, negative 1. And there it is. Question 17. Find the integral of x divided by 4 plus x squared dx. All right, this is a reverse chain rule. It's going to be a log because the denominator I've got 4 plus x squared to the power of 1. That's on the denominator, so that's going to be a log. And then I'm going to want to divide by the derivative of that inner function, which is 2x. Now I really want that to be sitting there, so I'm going to actually adjust it. I'm going to write it like this, 2x, 4 plus x squared dx. But of course I can't change the question. There wasn't a 2 there initially, so I'm going to need to adjust it like this. Does that make sense? Half of 2 is 1. I haven't changed anything. And now I'm ready to go. All right, this is going to be ln of 4 plus x squared and then plus c. Question 18. Differentiate e to the 2x and then in brackets 2x plus 1. Right, we've got a product rule, don't we? I always encourage my students to write this out formally. It stops errors. Okay. Now do our derivatives. This is actually a chain rule. So it's going to be e to the 2x multiplied by the derivative of this, which is 2. Take the time to tidy that up. and v dash will just be 2. That's nice and easy. Okay, here we go. We don't actually have any notation for this, so we can't really write y dashed equals, but we could write this. The derivative of e to the 2x plus 1 bracket is equal to, all right, u, which is e to the 2x, multiplied by the derivative of v plus v. Don't forget to put that in brackets there because you've got two terms, multiplied by the derivative of u is 2e to the 2x. Now at this point you've probably got full marks, but let's tidy it up. I'm going to expand these brackets out. What does that give us? 4x e to the 2x plus 2e to the 2x, and we can do one more line. 4e to the 2x plus 4x e to the 2x. There it is. Hence find the integral of x plus 1 in brackets e to the 2x. All right, so we probably need to go from one step further here. So let's bring out the 4e to the 2x, and that gives us 1 plus x, or they've written it like this. Okay, so again, just like I did before, I'm going to adjust this. So I am going to put my 4 in, because you can see how I've got a 4 here and there's no 4 here. And I can't just change the question. I need to adjust it. A quarter of 4 is 1, so I haven't changed anything. Okay, a quarter. Now we know that the integral of this thing here is going to be that there. So e to the 2x and then 2x plus 1 plus c. Question 19. Prove that sec theta take away cos theta is equal to sine theta tan theta. All right, with proofs we start with the left-hand side. You don't work from both sides. All right, so left-hand side is equal to sec theta take cos theta. Now sec theta is 1 on cos theta. Take away cos theta. Because I can see that this is all in one, all together, it's not separate terms, I'm going to join these two together with a common denominator. So cos theta there is 1 take away. If I'm putting a cos theta underneath here, I need to multiply the top by cos as well. So that gives us cos squared. And 1 minus cos squared theta is sine squared theta. We're nearly there. Can you see it? Here I've got a sine theta and a tan theta. Let's just separate it out. So I've got sine theta multiplied by sine theta on cos theta, which is sine theta tan theta, which is equal to the right-hand side. And there we go. There is our proof. Question 20. Kenzo is driving his car along a road while his friend records the velocity of the car v of t in kilometers per hour every minute over a 5-minute period. The table gives the velocity v of t at time t hours. The distance covered by the car over the 5-minute period is given by the integral between 0 and 5 over 60 of vt dt. Use the trapezoidal rule and the velocity at each of the 6 time values to find the approximate distance in kilometers the car has travelled in the 5-minute period. Give your answer correct to 1 decimal place. All right, so our trapezoidal rule is going to give us an approximation of this integral, and it is equal to the h over 2, whatever the height is of each of these things. It's 1 over 60, and then we want f of 0 plus 2 lots of f at 1/60th plus 2 lots of f at 2/60th, etc., plus dot 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 plus the very last one. Okay, so h is 1 on 60. I'm going to make that 1 on 120. Hopefully that's okay with you. Then we're going to go 60 plus 2 times 55 plus 2 times 65 plus 2 times 68 plus 2 times 70 plus 67, and I will leave you to work that one out. Okay, that's the end of booklet 1. In our next video, we'll look at booklet 2.